All right, here we go. Use the table. Shh, pay attention. Your test is tomorrow, so this is a very important day. Use the table and the information below to answer questions 1 through 3. Jessie wanted to know what type of cars people drive. After collecting her data, she recorded her data in the table below. Now, remember, I told y'all to make some changes to the first two questions. For this one, we changed it to males. And then this one, we just scratched that out, right? Okay, so number 1, what is the joint frequency of males who drive sports cars? What did y'all think? Correct. Well, just 39, okay, because we're not doing any kind of percentage, or they just want to know the joint frequency of males who drive sports cars. Well, if you go to males and you go over to sport cars, they join together at 39, so their joint frequency is 39. Now, which marginal frequency is the smallest? Right, marginal frequency are the totals. Remember how we just talked about the margins of a paper are the outside edges? Well, the marginal frequencies are the edges of the table, which are the totals. Well, the one that's the smallest is what? 60, which is males, right? All right, number 3. Which of the following statements is true? A, more people drive sports cars than SUVs. Okay, well, how many people drive a sports car? 84. So I'm going to write 84 right up above it. How many people drive an SUV? Okay, so is it true that more people drive a sports car than an SUV? Definitely not. Now, let me say something else. See how I'm writing the numbers above it, which kind of helps you see that it's definitely not true by putting those numbers down there? That's why I print a copy of the test for every single student I teach. Sometimes you may have a teacher who just makes a class set of 30 and tells the kids not to write on it because it's being used all day. But for math, I think it's very, very important for you to be able to write on the test. So take advantage of the fact that I'm wasting a lot of paper because I feel like it's helpful for you to be able to write on the test. If you turn in a completely blank test, I'm going to be concerned about what your grade's going to be when I grade it. Okay? You should be writing on the test. All right, B, pay attention. Less females were surveyed than males. Okay, how many females were surveyed? 180. How many males were surveyed? So is it true that less females were surveyed than males? No, triple the amount of females were surveyed than males. Okay, C, more males drive sports cars than SUVs. Collis, do you need something? An eraser? Does somebody have an eraser he can borrow? Okay, more males drive sports cars. Well, how many males drive sports cars? How many males drive SUVs? So is that true that more drive sports cars than SUVs? Yes, 39 is greater than 21, so C is the right answer. Okay, number 4. Using the table below, which statement describes the comparisons between the audiences who attended the movies? A says more adult females attended the movies than adult males. Well, how many adult females attended? Right, adult, female, the joint frequency of that is 29. The joint frequency of adult male is 27. So is it true that more adult females were there than adult males? How many more females? 2. So A is true. Now, you have plenty of time on this test because you have 2 periods tomorrow. So you should read through all 4 choices, okay? Even though you like A right away and you circle it, I would still glance through B, C, and D just to make sure, okay? Because you have plenty of time to do that. All right, are there any questions on that first page? Anything you feel like I need to go over any more? No? Everybody's good on the first page. All right, everybody turn to the next page. Numbers 5 through 8. All right, number 5. The graph below represents the growth rate of a plant in Tom's garden. The line of best fit is drawn for you, okay? See how they drew the line of best fit through the scatter plot? We're going to use this information to answer the question. Number 5 wants you to determine the equation of the line of best fit. Well, a lot of times we can find a line of best fit by going stat edit, put in the L1s and L2s, which are your X and your Y values, and then stat calc linear regression. But do you really want to sit there and try to type in the X and Y value for all of those points? No. That'd be pretty hard, right? It's a lot of points, and most of them are in decimal places, like 0.5 up, 1.1. That would take forever, okay? So we're going to do it by hand instead of by the calculator. What is the equation of a line? Right, y equals mx plus b. Okay, look over there to the right side of the room. Sizemore, will you point up there? Y equals mx plus b is slope-intercept form of a line. So they're wanting you to write the equation of this line. Well, to do that, don't we need a number for the m, the slope? And don't we need a number to go in the b place for the y-intercept? Well, out of those two things, which one's really easier? Which one's the easiest one? The y-intercept, right? Because the y-intercept is where the line hits the y-axis. Where does that line hit through the y-axis? Correct. Right there at 1 is the y-intercept. So we can go ahead and replace b with a 1. Now we've got to figure out what number goes in for m. Well, we have a special formula just for slope, and what is it? But that's not a formula. Now, what if you're working this test tomorrow and you can't remember the slope formula? What should you do? Sizemore, what should you do if you can't find the slope formula? Look, it's right up there too. Nobody should have an excuse for not knowing y2 minus y1 over x2 minus x1 because it's literally right up there on the wall. Okay? All right. So now, what do we have to have, though, to use this formula? 2 points. Good job, Angel. You need 2 x's and 2 y values, which is 2 points. Now, for picking these points, watch how I pick them. I'm going to go up the line a little, and then see how this point is sitting pretty much, I mean, it's a teeny bit below the line, but it's touching it. But it's in a nice location because to get to it, you go right 4 and up 3. So that's a nice point to use because its x and its y value would be whole numbers because it's sitting right there on the grid line. Okay, and then if you continue on up the line, I think the next nicest point is probably like right in here. Those two kind of split that. This one? Yeah, I'm using the very last one. And where is it located? 8, 5, because you have to go right 8 and then up 5. Now, it does not matter which one you label which. I just normally stay in the habit of the very first one I wrote. I label it as my x1 and my y1, my first x and y value. And so that means 8, 5 would be my x2, y2. But even if you did that vice versa, you should still get the same answer as long as you're doing the formula correctly. So basically you're giving them their own unique name, and now they have a seating chart that they go into. So who gets to sit in seat Y2? Right, because that's what we named number 5. Then minus, who gets to sit in Y1? Right, who gets to sit in X2? And then minus, don't forget the minus both times, and who gets to sit in X1? Correct. Now you need to reduce. What is 5 minus 3? What is 8 minus 4? Right, that'll reduce again to 1/2. So now we have the slope of 1/2 and the y-intercept of 1. So your equation is y equals 1/2 x plus 1. Now tomorrow you'll have 4 choices. Okay, you'll have 4 equations. So you can narrow it down by looking at the line. If the line's going up, your m value should be positive. If the line is going down, your m value should be a negative number. So you could probably cross out some wrong answers by just seeing if the line's going up or down and picking an appropriate slope. Does that make sense? Like we shouldn't have an m value that's negative for a line that's going up. You might also be able to narrow it down by looking at the y-intercepts. This one obviously crosses the y-axis at 1, so there should definitely be a 1 in the b place. Okay, you should at least be able to narrow it down to 50-50, even if you had to guess from there. But say you've narrowed it down to 2 choices that both have a positive slope and both have a y-intercept of 1. At that point, you would need to pick 2 of the points and calculate the slope. Okay? Where it hits the y-axis. And the m is always the slope, what you get when you pick the 2 points and plug them in. But that's the last thing you should have to do. You should be able to narrow it down to probably at least 2 choices before you have to do the m. Okay, now, what does the y-intercept tell us about the graph? Okay, well, what is the y-intercept? Right, and as a point, wouldn't that be the point 0, 1? Because we didn't go anywhere on the x-axis, so the x value is 0, but the y value is 1. Now, in terms of this problem, we're talking about a plant growing in Tom's garden. What does the 0 represent? The week. Look, isn't the 0 on the x-axis, so that's weeks? So 0 weeks. The plant is 1 centimeter tall. So what it represents is the plant was already 1 centimeter when he started observing the growth. Okay? Now, it could be worded a little bit differently. Like, instead of saying the plant was already 1 centimeter tall when he started observing, what else do you think the question might, or the answers might say? Like, do you always have to plant something, throw seeds in the ground and watch it grow? What else can you do if you want to have a garden? Yeah, you can go buy one, and so couldn't the plant have possibly already been 1 centimeter tall when he planted it? Okay, but regardless, when he started doing his observing or whatever he's doing, watching it grow, the plant was already 1 centimeter tall. Whether that means he bought it that tall or whether it means he threw the seeds in the ground and didn't start watching it grow till it was 1 centimeter tall. Does that make sense? Okay, number 7. The linear regression equation for a data set is y equals negative 2.1x plus 63.5, where y represents the number of balloons sold by a party store each week and x represents the week number. Use the equation to predict the number of balloons the store will sell during week 8, round to the nearest whole number. Now remember, you're going to have a test that you can write on. You can underline things, you can circle things. So what's some important information here? Right, so I might underline that, or I might even go ahead and bring it down because you pretty much know you're going to have to use that, right? Correct. So down here, you might want to put like an arrow and put balloons or the Y. Okay? And so we know this is balloons. What is the X? Weeks, right. It says X represents the week number. So 8 is a X value because it's weeks. So wouldn't that mean we plug it in for X? So in your calculator, what does it mean when negative 2.1 and X are touching? What operation is that? Multiplication. So it'll be negative 2.1 times, which we represent with parentheses, 8, and then plus 63.5. So go ahead and type that in. Everybody needs to pick up their calculator and type it. Nobody's going to be typing it for you tomorrow. Okay, right. Okay, if you don't know how to type it in, please ask your partner or raise your hand and one of us will come help you. Okay? Has everybody had a chance to type it in now? Okay, and you should have gotten 46.7. But we're talking about what? What does the Y represent? Balloons. Can you have 46.7 balloons? So we'll just go and round that up to 47 because balloons would be a whole number, right? All right, number 8. Y'all still copying that? Okay, we good to move on? All right, number 8. Which set of data would a linear model best fit? This is asking which one of these tables would make a line when you plotted those points. Okay, well, there's one reason I don't like this question. Okay, so let's talk about that because you're going to see it like this tomorrow. Normally, when a table is created and it's done sideways like these are instead of vertical, normally they do the X on top and the Y on bottom. Okay, that's normally how you see it. But all of these tables are the opposite. The X's are on bottom in each one and the Y's are on top. So you got to pay attention to things like that. Now, look at the X's for every single table. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So obviously, since all the X's match, that's not going to tell us a lot, right? We need to look at the Y values. For A, 25, 35, 45, 55, 65. So what's the pattern here every time? Plus 10 every single time, right? Now for B, 25, 35, so it starts off as plus 10, but then 35, 15. Isn't that a drop of 20? And then it goes back up. No, that's a drop of 20 from 35 to 15. And then 15 to 25 is up 10 again. And 25 to 18 is down 7. Okay, now let's look at C. 5 to 7 is up 2. 7 to 10 is up 3. Up 5. And then up 10. For D, we go down 10, down 5, plus 5, and plus 10. Okay, to be a line, to be a linear model, it has to have a constant rate of change, which means it does the same thing every time. And the only one that did the same thing every time is A. Now, there is a pattern in D, but let me show you what kind of pattern it is. Okay, but look if I plotted these points. Say I have a quadrant 1 and I go over 1 up 25. Correct, it's nonlinear. And then if I go over 2 up 15, that would be about, if this is 25, we'll say 15 is about right there. Then over 3 up 10 would be a little lower than 15 was. But then 4, 15 would be back in line with that one. And 5, 25, so it's quadratic. It makes a U shape. This is a good fit for a quadratic function. This is a good fit for a line. Does that make sense? All right, now let's go to question 9. Which set of data could be best modeled by an exponential function, linear function, quadratic function? So we're going to do, this is not like a multiple choice, but tomorrow it will be. We're going to do each one, A, B, C, and D. All right, for A, would this best be modeled by an exponential function, a linear function, or a quadratic? Linear. Okay, those are in a straight line. Yeah, it is kind of confusing. Tomorrow it will be multiple choice, and only one of these will be up here, and you'll circle the right one. Okay, B, right. Even though you can't see the rest of it, you can see that that's making a U shape, and a U shape is a quadratic function. Okay, it does have correlation, but remember we talked about this. It's non-linear correlation. Okay, C. This has no correlation at all, so it wouldn't be represented or modeled by any of those functions because there's no correlation. And then D, no. That's also a negative line. Oops, I didn't draw it very well. Okay, that would also be linear, but it would just be a negative correlation. Exponential is a curve, so it would start out kind of looking like a line, but then it would start curving like this, kind of like half of a U. It never goes back up on this side. It goes straight. That's what exponential looks like. Okay? All right, now let's look at number 10. A service company maintains several ovens. The table summarizes the temperature setting and the actual oven temperature. Using the equation of a line of best fit for the data, which is the estimate of the actual temperature for an oven set at 425 degrees. Okay, so using the equation of the line of best fit, did they give you the equation for the line of best fit for this data? No, I don't see an equation anywhere in here. I don't see a y equals mx plus b, so how can you get it? Right, you put this in the calculator. This would go in L1, this would go in L2. So go ahead and enter the data. What did y'all get for the slope? 0.5, and that always goes beside the x. What did you get for the y-intercept? 70. Shh, pay attention, guys. All right, now we have the equation, so now we can actually use it to figure out the actual temperature. What is the actual temperature, an x or y value? Right, the actual temperatures are over on the right, which are your y value. So we want to figure out the y value when the oven is set, which is an x value at 425 degrees. So you just plug in 425 for the x. Okay, so does everybody know how to type this in? 0.5 parenthesis 425 parenthesis plus 70. If you don't know how, please get your partner to show you. If they don't know how, please come up here and we'll show you. So far, I've only got one on that list. Yep. Yep. It's multiple choice tomorrow. Except for like maybe just a couple of parts. I can't remember. Most of it's multiple choice. Okay, what'd y'all get? Right, and isn't that degrees? Because that's the actual temperature when the oven has been preheated to 425 degrees. Okay, here we go. Above is a scatter plot showing the temperature versus cells of ice cream. Okay, so we have a scatter plot. The temperatures are in the x-axis. Now look, they're in Celsius, which is why they're so low. Okay, and then the y-axis is cells from $0 to $700 for ice cream. This plot, pay attention, indicates that there is a blank correlation between temperature and ice cream. What? Positive, right, because the scatter plot points are going up from left to right. Now, Caden, do you think this would be strong positive or weak positive? If you were to draw a line of best fit, would it be strong positive correlation or weak positive correlation? Strong, because see how most of those points are very close to that line? So strong positive. Okay, that would definitely have an R value, a correlation coefficient greater than 0.70, right? It'd probably be like 0.80, maybe even 0.90. Okay, number 13. Given the information below, which graph has an approximate correlation coefficient of R equals negative 0.49? So we've got a correlation coefficient equal to negative 0.49. Now, with multiple choices, what's the first way to mark out some wrong answers? Correct. If your R value is a negative, then you can mark out the lines that are going up because those would have positive correlations. So B and C are out. Now, is this considered strong negative or weak negative? That would be weak, or according to our definition that I think I gave you one day, didn't I call it like moderate? So, which one would it be, A or D? D. A correlation coefficient for A would be something like what? Negative. Guys, I need you to all pay attention and focus. What would be an estimate for the R value of A? Okay, negative 0.98 would be good because it's almost perfect, right? It's almost close to negative 1, but there are some points that are a little bit off. Okay, so not quite negative 1. Shh, I need everybody to remember that tomorrow you're taking a test. Tests count the most in this class. Think about that for a second and then think about, is it more important that I sit here and talk to my friend or more important that I pay attention to the review sheet that looks just like tomorrow's test? What's more important right now? Right, the review sheet. Okay, you can talk to your friend later. All right, number 14. Which graph most clearly shows a strong positive correlation between X and Y values? Well, the only one that's even positive is A. B would be a weak negative. C would be a strong negative. I'd say D is really, no correlation. If anything, a very weak positive, but I'd probably say no correlation. All right, number 15. I'm still seeing some people that I don't think are paying attention. Which statement suggests causation? Oh, you got a question? No. This like in the past, some of our tests have had more than one answer, but this test, there's only one answer for every problem. I know, yeah, that should have been taken off. Okay, which statement suggests causation? Like one thing caused another one to happen. Do you got a question? I know, remember I made changes but lost them on my drive. See, you brought it up again. All those things I lost. All that hard work is gone. Okay, I'm going to read through all 4 of them. When you study for math, you make a higher grade on your math test. When you study for a test, your classmates study too. When it's raining, you carry an umbrella. When you get pizza at lunch, your friend does too. Which one causes the other one? A. Okay, let's talk about the other choices and why they don't. Well, no, there is correlation, but it's also causation. Yes, anytime there's causation, then there is correlation also. There can be correlation and no causation. If there's causation, there's definitely correlation. Like for instance, C would be just correlation because most people when it's raining carry an umbrella. But does raining cause you to carry that umbrella? No. There's people that walk in the rain. It does not cause you. But studying for your math causes you to make a higher grade. Now, it might not be an A, B, or even C, but I assure you, if you study, you will make higher than you would have made had you not studied. Even if it's only by 5 points, studying causes a higher grade. It may not be as high as you want, but it will be higher than it would have been. Does that make sense? Okay, now let's go to the last page. Last page. Maybe you need to learn how to study. Let me quickly show you what is not studying problems. What does a correlation coefficient of R equals 0.99 imply about the graph of a data set? Well, break it down. Okay, split it up. A and B say the slope is negative, while C and D say the slope is positive. Is the slope negative or positive if that's right? If your R is positive, your slope is positive. So A and B are out. Now let's look at the other part. If it's 0.99, is a linear model a good fit or not a good fit? It is a good fit. What they mean by a linear model not being a good fit is like if you had an R value of like 0.4, wouldn't the points be scattered out a lot and you might not know where to draw a line? That's what that means by not a good fit, is if you had trouble figuring out where to draw a line, which means your R value is getting closer and closer to 0. If your R value is close to 1, it's easy to draw a line. The points pretty much make the line for you, right? Okay, this next question, in my opinion, is going to be the hardest one on the test. Okay, all you got to do is pay attention right now, and you shouldn't have a problem with it. Okay, so focus, because this is going to be probably the hardest one. So as long as you pay attention, it shouldn't be that hard for you. Everybody ready? The data below represents the life expectancy of the cat population of a certain country from the year 1900 to the year 2000, based on years of birth. They bolded this for a reason. Let the year 1900 be x equals 0. So they're telling you that the years are the x values, and they're telling you instead of using 1900, rename it as 0. So now you have to decide what that means about the rest of these years. What would 1910 be renamed? 10. From 1900 to 1910, isn't that a 10-year period? And so what would we rename this one? Right. And so what about this one? Right, because in the year 2000, hadn't that been 100 years since the year 1900? Okay, so now it's renamed, and now we're going to answer these questions, part A and part B. What is the best fitting linear line for the data? So they basically want the best fit line in y equals mx plus b form. How do you do that? Right, go ahead and put that in your calculator. Okay, so we now have the line of best fit for this data. We did it by putting the year in L1, and remember we changed our years to 0 through 100 instead of giving the years that were there. And our y values went in L2, and those were the life expectancy. Like this is 9.24 years, 11.49 years, and so on. Once you put them in there, you go to stat, calc, linear regression, which is number 4. And then when you calculate it, it gives you your A and your B, which goes in the place of the slope and the y-intercept. Now that we have our equation, it says based on the data, what is the life expectancy for a cat born in 2020? Well, remember, this would have been like 2010, and then after that, it would have been 2020, right? Which I'm running out of room. So what would that have been when we renamed them? 120, okay? Because from 1900 to 2020 is a 120-year period, right? Okay, well, where do we put the 120? Guys, where do we put the 120 in the equation? The x. Right, because remember, look, what is the life expectancy? Life expectancy is a y, so we don't know the y. We're trying to figure it out. We know the cat was born in the year 2020. We know the x value, but we've converted it from 2020 to 120. So it'll be 0.07 times 120 plus 10.2. And so what do you get? Right, so the cat would be approximately 18.6 years old. That's the average life expectancy for a cat in the year 2020 according to this data. All right, why do you think life expectancy of a cat would have increased, would double from the year 1900 to now? Well, right. Don't more people like take their animals to veterinarians if they get sick? Do you really think people in the 1900s had money to spend on taking an animal to the doctor or even buying it like a lot of food and snacks like we do for our animals this day and time? No. What was the main use for an animal in the year 1900? Work. Right. So they didn't even really care about like pets. They needed animals to survive for work and to provide them with food and eggs and milk and everything like that. So cats weren't important unless they were eating them, right? Okay? And that's not really been something that we've done in this. Right. So this probably isn't Japan, right? This is probably another country that doesn't really need cats. Shh. Okay, last problem. Shh. Refocus. Shh. Last problem. I'm waiting on everybody to turn around and let me know that you're paying attention to this last set of problems. Yes? In a minute. Let me get it started first. Okay, here we go. A group of students were polled to find out how many were planning to major in a scientific field of study in college. The results of the poll are shown in the frequency table below. Number 17 says find the marginal frequencies. What are marginal frequencies? Totals. So, Ty, can you fill in the totals for us? Grand total, okay. Does everybody agree with these marginal frequencies, the totals? Okay, now, your test tomorrow, it's just going to be just like this. On your test, you'll actually have to write them in. Now, on the actual Scantron that you get, this is what it will look like. No, it'll look like this. Okay, you will not do anything on this Scantron part. That's for me. Like, I'll look. This is why it's so important to also write your name on your test paper, and we're going to keep them together. Your test will go right up under your Scantron when we turn them in. Because I'll open up your test, and I'll say, oh, look, Ty got every single number right, so I'll bubble a 5. Or maybe Ty got all of them right except one, so I would bubble a 4. Your job is not to bubble here. Your job is to fill them in, and I'll go through and bubble how many you got right. Does that make sense? Okay, so we're done with 17. Number 18. Out of the juniors, what percent are not planning to study a scientific field? Okay, Ty, what did you do first? Okay, because that's how many juniors are not doing science is 271, right? Divided by, no. Divided by what? Right. Right. So how many, this is only out of juniors. How many juniors are there? 401. So you divide it by 401 because we only care out of the juniors what are not planning to study science. So look, out of the 401 juniors, 271 of them are not doing science. So 271 divided by 401 is what? Okay, because what's the number after 7? Okay, so 68% is right. Okay, now B. Out of the seniors, what percent are pursuing a science field? Well, 129 is the seniors that are doing science out of the seniors, which is 274. And what percent is that? 47%? Yeah, 0.47 as a percent would be 47%. Okay, are there any questions off this page? Any that you need me to go over again?